Welcome to a lesson with Dr. Powell. Let's take a look in this video at how we can use L'Hopital's rule in order to compute this limit. But we're going to do this in a few different ways and show you a couple different ways we could use L'Hopital's rule in order to do this. So first of all, part of this, when you plug in 0, like what's the problem parts? Like what makes this go to 0 over 0? I mean, essentially you see this x and that sign, both of those are zeros, right? And then when you plug a 0 in here, you get a 1 minus 1. But the cosine really is doing nothing, and neither is the 5. So let's just put those off to the side. That makes it a little bit simpler. Okay, because when you plug in 0, hey, that's just, 5 times cosine of 0. That's 5 times 1, that's 5. Limit of that part's 5. And then we just left with, let's just write down the problem issues so that we can really concentrate our efforts. X sine x all over e to the x minus 1 quantity squared. Now, if we want to be even more clever here, we could just simply write this down and split it up into different, because we have like 2 problems on the top and 2 problems on the bottom. Why is it 2 problems? Because it's squared. E to the x minus 1 times e to the x minus 1, and x sine x. All those guys are going to 0, so you're making zeros over zeros. So we could really write this as like x over e to the x minus 1 times sine x all over e to the x minus 1. And really, if each one of these parts has a limit, then the limit of the whole thing is just the limit of the parts multiplied together. So this part right here just simply limits to 5. This part, we can use L'Hopital's rule because it goes 0 to 0, and it does work nicely. Derivative of the top is 1, derivative of the bottom is e to the x. So you think, 1 over e to the x as x goes to 0. Hey, that's like 1 over e to the 0. E to the 0 is 1, so 1 over 1, that goes to 1. What about this part? Let's think about that. The derivative of the top is, because 0 over 0. Derivative of the top is cosine. Derivative of the bottom is just e to the x. And then as 0 comes in, you get it 1 over e to the 0. It's 1 over 1. It's 1 again. So the limit of the whole thing is 5. That was pretty snappy. All right, now if we didn't split this up this way, though, and we just started from here, we could still proceed because this goes to 0 over 0. So we could take derivative of top and bottom. Derivative of the top is the product rule now. So we have, and I'm just going to focus on this computation. I know this part goes to 5, so 5 times whatever that part goes to, which apparently will be 1. But let's just work through the steps with L'Hopital's rule. Derivative of the top using the product rule is 1 times sine of x plus x times the cosine of x all over, and we're going to be taking the limit of this part as x approaches 0. You can use the chain rule here, put power rule 2 e to the x minus 1, because something squared, 2 comes down. But then you have to multiply by the derivative of the inside, which is just e to the x. Boom. All right, now issue. If you plug in 0 again, you again get 0 over 0. So let's use L'Hopital's rule again. See how this other way was so much nicer? Let's keep going and see what it is like. So the derivative of this top part, because this is 0 over 0, maybe we should double check it. Sine of 0 is 0, and that x is 0, so top is going to 0. Bottom, e to the 0 minus 1, that's 0. Okay, so we're good. Derivative of the top is cosine of x, and a little product rule there, plus 1 times cosine x minus x sine x, because the derivative of cosine is negative sine, then times x. All right, all over, we need a product rule down here. All right, or I mean, we could do product rule, or we could distribute this, and I mean, you could do that too. I'll keep the 2 outside, but let's just distribute the e to the x in. As the e to the x goes in, you get like e to the x times e to the x. And you know what e to the x times e to the x is? It's just e to the x plus x, or e to the 2x, right? So you can think of this as e to the 2x as e x multiplies to that, and then minus e to the x multiplies to the 1. And I like that because it's like 2 times something, so it's just like the derivative is just 2 times the derivative of that part right there. So 2 times derivative of this, little chain rule here. Derivative of e to the something is e to the something, but then times the derivative of the something, which in this case is 2. So 2 e to the 2x, and then here derivative of that's just minus e to the x. Okay, have we made any headway on this? Let's see. Well, the top's not 0 anymore. Hopefully I did that right on that part, because like, oh yeah, I think so. So the top is not 0 anymore because this part of course goes to 0 as x goes to 0, but this part right up here goes to 2 because cosine of 0 plus cosine of 0 is just 2. 1 plus 1. On the bottom, let's see what we get. We get that 2 hanging out. And then here, e to the 2x, that part goes to 1, and e to the x goes to 1. So this part goes to 2 times 1 minus 1, which is just 1, right? 2 minus 1, so 1. So 1, oh, that's beautiful, 2 over 2. That goes to 1. As desired, this part, this problem issue part right here, will go to 1. This part goes to 5, and so we know it's 5 times 1. Which way did you like better? And in fact, that's probably all the ways we'll do. Okay, just this way and that way. But this way was nice. See how quickly we could get it just by thinking through this and what parts, you know, really give the 0 over 0 versus not. And this part, one simple L'Hopital's and one simple L'Hopital's were done. Of course, here, more derivative stuff to work with and double L'Hopital's there. So hopefully you can glean something from this particular example on the use of L'Hopital's rule. Thanks for watching.